topic in this unit before the mid-unit test is going to be solving quadratic equations. We're going to use two methods. We'll eventually add to this, but right now we're going to use factoring to solve and we're going to use square root method to solve. You've actually seen both of these throughout, spread in the notes a little bit and in openers. So we're going to go through a couple of examples and then you're going to finish these up. You'll get this example sheet in class if you happen to see the video ahead of time. So the first thing we're going to do is, if you look at number 4, it might make sense to add over the 16, and so you would think of that as x squared equals 16. We would need to take the square root to solve. That's fine, but remember, when you take the square root of a variable, that is the absolute value of x equals the square root of 16, which is 4. And you've got to write that piecewise equation if you're going to use an absolute value. So we would get a a positive x if x is greater than or equal to 0. We would get a negative x if x is less than 0. Those two pieces would be our equation. So I would say x equals whatever the absolute value equals, so it equals 4. I also have to say negative x equals 4 as well. So divide by -1 and we get x equals -4. That gives us our two solutions. And we can write those as a solution set of 4 and -4. This is not an ordered pair. That is a set. The brackets tell you it's a group of numbers, not an ordered pair. If you did that, that would be fine. It's a little more work to do it that way than if I chose to factor this. This is a difference of squares. I could say that's x minus 4 and x plus 4 equal to 0. So I just set both pieces equal to 0 and x equals 4, x equals -4, and there's my two solutions. Your choice, but if you choose to solve it this way, you have to write the piecewise and show the work for that. All right, on 5, the first thing is it's not equal to 0. Anytime you're solving a quadratic, you have to get it equal to 0. So the first thing I'm going to do is subtract that 35 from both sides. And when I try to subtract that on the left, there are no like terms. So I get 2x squared plus 3x minus 35 equals 0. If you've got if you don't have a difference of squares, you might want to just try to factor immediately. This is going to be trial and error. So I get 2x and x. I could use 1 and 35 or 5 and 7, I believe, are my only choices. This does wind up being -7 and plus 5. So that I get 10x and a -7x, which gives me the positive 3x in the center. All I have to do to finish out, once I get it factored, is set those pieces equal to 0. And so I get 2x minus 7 equals 0, 2x equals 7, and x equals 7/2. The other piece, I just get x equals -5. So again, that's the set of numbers, 7/2. You can call that 3.5 if you'd like, and -5. All right, take a look at number 8, if you would, please. The issue with 8 is, again, it doesn't equal 0. So I'm going to add the x over. Again, I don't have like terms. When you're adding a piece over, you want to make sure, I didn't point this out on the last one because we tacked the number on at the end, which was in descending order, but we want to make sure that we have it in the squared, then the x, then the constant, descending order by the powers. So that's 6x squared plus x minus 1 equals 0. That one also will factor. We're going to get 2x plus 1 and 3x minus 1. Again, there's our -2x and our positive 3x, which combines to give us 1x in the center. Set each piece equal to 0. And at that point, we wind up with a set of numbers -1/2 and a positive 1/3. That's our solution set. Then we wind up with number 9. When you are in some form of vertex form, you could multiply it out. The easiest thing to do is going to use that square root method that we kind of looked at over here and said, well, if you can factor, it's easier. On number 9, we can't factor. So on this one, the first thing you want to do is now move that 2 over. We want to isolate the factor that's being squared. So I'll subtract my 2. That quantity squared equals -2. I'm going to divide both sides by -3 to get rid of that. So I get x plus 4 quantity squared equals positive 2/3. From here, we do need to take the square root of both sides. When I do that on the left, that just gives me absolute value of x plus 4. Yes, I am going to have to write a piecewise function. Over here, that is the square root of 2 over the square root of 3. We don't want to leave a radical on the bottom, so we are going to rationalize. I'm going to do that before I write that down here with my absolute value. I'm going to multiply that by root 3 over root 3, which will give me root 6 over root 9. And what is the square root of 9? Hopefully you know right off that's a 3, and the root 6 stays on top. At this point, then that piecewise function, absolute value of x plus 4, gives us the 2 pieces, a positive x plus 4 and the opposite of that, negative x minus 4. My domain piece for x plus 4 is going to say if x is greater than or equal to -4. So this will be if x is less than -4. And we know that the absolute value equals root 6 over 3. So when I write the 2 equations, x plus 4 equals root 6 over 3, and negative x minus 4 equals root 6 over 3. When I solve each of those now, I'm simply going to subtract 4, and normally you'll see the answers written with the non-radical number first, so I would see the -4 plus root 6 over 3. There's nothing really wrong with that answer, but a lot of times you'll see them combine those two also, so they would find a common denominator of 3. Whoops, don't stand too close to the board. Common denominator of 3, so that would be a -12 over 3 plus root 6 over 3. These two numbers can't combine because one's a radical and one's not, but that would be -12 plus root 6 over 3. Again, the red is not a bad answer, it's just a lot of times you'll see it combined like this. And when I solve the second piece, I'll add my 4. So that will give me a positive 4 plus root 6 over 3. But that equals a -x, so I have to divide everything by a -1. That will wind up giving me a -4 minus root 6 over 3. Again, that common denominator times 3, so that's -12 minus root 6 all over 3. These two pieces would be very nice answers, right? I'd like you to take a couple of minutes and work through each of those. So if you would pause the video for the moment and work through the other 4 on your sheet. And when you're finished, you can restart the video and the answers will be on the next screen. Thanks.